Welcome to Section 1, Introduction, Embracing the Power of Objects. Object-Oriented Programming, or OOP, is a powerful paradigm that has revolutionized software development. It's more than just a coding style, it's a way of thinking about problems and their solutions. At its heart, OOP allows us to model real-world entities as software objects. These objects encapsulate data and the methods that operate on that data. Think of it like building with Lego bricks. Each brick has its own properties and functions, and you can combine them to create complex structures. In the world of software, these bricks are objects, and they hold data, known as attributes, and actions, known as methods. Imagine you're building a car in code. A car object might have attributes like color, model, and speed, and methods like accelerate, brake, and turn. This approach brings numerous benefits. It enhances code organization, promotes reusability, and makes maintenance a breeze. OOP allows developers to write modular, scalable, and maintainable code by breaking down complex systems into manageable objects. The beauty of OOP lies in its ability to mirror the real world within our code. This makes software easier to understand, modify, and maintain. By modeling software after real-world entities, OOP allows for intuitive design and implementation. This paradigm shift from procedural to object-oriented programming has led to more robust, adaptable, and scalable software systems. Welcome to Section 2, Encapsulation, Safeguarding the Blueprint. Encapsulation is one of the 4 fundamental principles of OOP. It refers to the bundling of data and the methods that operate on that data within a single unit, the object. This bundling serves as a protective barrier, preventing external code from directly accessing or modifying the internal workings of an object. Instead, interactions with the object occur through well-defined interfaces or methods. Think of a capsule, encasing medicine within a protective shell. Similarly, encapsulation safeguards an object's internal state, ensuring data integrity and preventing unintended side effects. Access to this data is controlled through methods, much like a pharmacist dispenses medication. This controlled access ensures that data is accessed and modified in a predictable and consistent manner. In Python, we can achieve encapsulation by using access modifiers. These modifiers, such as public, private, and protected, dictate the level of access allowed to the attributes and methods of a class. While Python doesn't enforce strict access control like some other languages, we use conventions like underscores to indicate private attributes. For instance, in our car example, the engine attribute could be made private, denoted by a leading underscore engine. This signifies that it shouldn't be directly accessed or modified from outside the car class. Instead, we would define methods like start_engine and stop_engine to interact with the _engine attribute in a controlled way. This controlled access mechanism is central to the concept of encapsulation. Welcome to Section 3, Abstraction, Simplifying Complex Realities. Abstraction goes hand in hand with encapsulation. It allows us to focus on the essential aspects of an object while hiding unnecessary complexity. Think of a car's steering wheel. You don't need to know the intricate mechanics of the steering column, gearbox, and tie rods to turn the car. You simply turn the wheel. That's abstraction at work. In programming, abstraction lets us interact with objects at a high level without worrying about their internal complexities. We work with simplified representations, focusing on what an object does rather than how it does it. This simplifies development and reduces the cognitive load on programmers. By hiding the implementation details, abstraction allows developers to focus on the bigger picture. Consider a coffee machine class. Users care about making coffee, not the intricate heating elements, pumps, and brewing mechanisms. Abstraction lets us define methods like brew_espresso or steam_milk without exposing the complexities of temperature control or pressure regulation. The user interacts with a simplified interface, making the coffee machine easier to use and understand. This concept of abstraction is powerful because it allows us to create reusable modules. We can change the internal implementation of the coffee machine class without affecting how users interact with it, as long as the public interface remains consistent. This separation of concerns is a cornerstone of good software design, facilitated by the principle of abstraction. Welcome to Section 4, Inheritance, the power of reusability. Inheritance is a powerful mechanism in OOP that allows us to create new classes, or child classes, based on existing ones, known as parent classes. This promotes code reusability, one of the key benefits of OOP. The child class inherits the attributes and methods of the parent class, extending or modifying them as needed. Think of a family tree. Children inherit traits from their parents, and OOP mirrors this concept. This inheritance hierarchy allows us to represent relationships in our code. For example, a sports car is a type of car, inheriting its fundamental characteristics while adding specialized features like a more powerful engine or aerodynamic design. In Python, inheritance is implemented using parentheses in the class definition to specify the parent class. If we have a vehicle class with attributes like speed and color, we can create a car class that inherits from vehicle, automatically gaining those attributes. The car class can then add its unique attributes like number underscore of underscore doors or fuel underscore type, further specializing the inherited characteristics. This hierarchical structure not only promotes code reusability, but also reflects the natural organization of real-world entities. Inheritance allows us to model these relationships, resulting in cleaner and more maintainable code. It's a powerful tool for representing shared characteristics and behaviors within a software system.